If you go to the lowest level, it will be a micron. So always above that. And the dimensions of the unit cell, I hear for you, found in a paper published in 2018, probably American Ceramic Society. These are the latest parameters, A and C of H2O and A and C of D2O. So what structure they are? Can you tell me? Can you guess from the parameters? When B is missing, this means A is equal to B, not equal to C, which is tetragonal. It is really surprising that you couldn't understand this simple thing, right? A is given, B is not given. This means A is equal to B. If only A is given, then this will mean A is equal to B is equal to C, and it will be cubic. So my aim was not to teach you crystallography by showing this, but look at the difference. 4.49673 and 4.49728. The difference is 0.001 something or less than that. 0.001 angstrom or less than that. Similarly, the C parameter 7.322 and 7.324, 0.002 is the difference. Can you measure that with something whose resolution is not of that level? Never. Because when you look into the X-ray diffraction pattern, 100 and 100 of H2O and 100 of D2O. The A plane 100 both will be almost the same, right? Similarly, the C, they will also be almost the same. That is why I am stressing upon the fact that the X-ray crystallographer must be very, very careful, right? Don't jump onto the results. First, look into things very carefully. That is it matching D2O or H2O? There may be other compounds like that. So check all the relevant compounds. But common sense should also not go there, right? Common sense should also be used every time. A camel cannot be hidden in the hand, right? So if I ask you what is in my hand, it has 4 legs, a long neck, and this much tail, and there, and you say camel. So a camel cannot be hidden in a palm, right? So when you are interpreting your data, look into your compound, the composition, that what sort of materials you have put there, or what sort of material are you expecting there. Then look into all the possibilities. If the whole research project is characterization and properties of a sample, X-ray takes 1 hour per sample, 10 samples in 10 hours. Properties, sample preparation, a sample can be prepared for XRD in a few minutes. It is not a difficult thing. Either polished or ground into powder using pestle and mortar or any other grinder to take it to that small particle size. Properties may hardly take a day. Can a person do his PhD in 2 days? Never, because he is not supposed to do things as they are. He is struggling to do the things in his way or her way. But if they get the diffraction pattern of H2O, crystalline H2O, they have to check all the other possibilities. Right? And that thing takes time because you have to scientifically prove, analyze, and do things and use all the precautions there. And one go, people can never do things like that. So that is why I am showing you this, that there are very small differences among different structures. But using the simplistic approach, that if single crystals are not available, then you have other two options. I will say three options. One option is this, that you make powder of your sample. Make powder of your sample and put it in the sample holder, fix it. Always be careful that your grinder must be very, very clean. What people I usually do, wash it with water. Grind it with some cloth or something so that nothing brush should be used. If there are minor pores inside the pot, that they are cleaned up. So use water to clean it up properly. Then brush it with acetone or something like that. Then put acetone and shake it, move it around and pour it. So make every effort possible to you to clean the pot intimately. The same should be done with the pistol, right? It should be also very clean. Then dry it in the drying oven. When it is dried properly, then put your sample and grind it. I usually use new paper to pour the sample into. When it is new paper and there is no dust upon it, then I pour it into the bottle. Then you pick the sample with something clean, very clean, onto the sample holder. The sample holder should also be clean. The environment in the X-ray sample holder place where you put the sample, that should be also very clean, because you are dealing with particles of the dimensions of angstroms, and there may be something in the environment which can contaminate your sample. So you must be very, very careful. Then you take it to the sample holder, and the powder sample is preferred over the other forms of samples because the crystals are oriented randomly inside the sample. Right? The crystals are oriented randomly inside the sample, and random, I have given you the example that if you all look down in this window, the people will think that there are only hits in this room. But if somebody comes inside, then they will say that there are bodies as well. So when you put a solid sample inside a material, and the material crystals has preferred orientation, they are not randomly oriented inside the solid sample, then they are giving you misleading results, because they are giving more intensity due to that specific plane in comparison to the other. And for example, theory will tell you that the intensity of that particular plane should be 80%, and it gives you 100%. So it is misleading you, because you can't decide then. The intensity is not matching. When you match the X-ray data with a standard card means that globally there are more than 100,000 crystallographic data cards published, globally used as reference materials. What these cards have? These cards have 2 theta angles. These cards have the value of interplanar spacing, the D value. These cards have the HKL indices. These cards have A, B, C, alpha, beta, gamma, lattice parameter of a crystal unit cell. These cards have volume of the unit cell. They have the crystal system, whether it is cubic or rhombic, tetragonal, triclinic, or whatever crystal system it is. Then they give the space group, and which space group they can be placed. So all this information is published on that data. And from MRL, we have 15 cards in that global data. Our previous student did some excellent work, and I published those cards on the ICDD available data files, right? So when you get your XRD pattern, the first thing is to get the interplanar spacings, 2 theta angles from that data, and intensities. Different softwares which reads the XRD provided data files. There are different X-ray specific programs by which they can auto-label all the peaks present. But auto-labeling is not usually perfect, because if a spike has come from somewhere,